Good morning. Good morning,
Good
sir.
morning. Good morning, sir.
Good morning. Good morning. Are you set to go?
Hello, sir. Yes, sir. You are visible, sir, and audible also.
Thank you. Thank you.
Okay.
Can I just share and see the presentation? Hello.
Yes, sir. Now you are the presenter, sir. Now you can test your presentation, sir.
Exactly. Thank you. You can see?
Yes, sir. Your presentation is visible, sir.
Hello, Mr. Raju. I am audible.
Yes, sir. You are audible, sir.
Okay. A very good morning to all the distinguished dignitaries, panelists, and the participants.
Anil, little light is less. Kindly
Sir,
put more
actually,
light if possible.
sir, there is power cut in my.
Okay. Then, all right. If any windows, then open them.
Yes, sir, I have already
Nearby.
opened the windows.
Okay. Right.
I am an
Because-
young professional Center for Hill Development, Geometeorological Risk Management Division, National Institute of Disaster Management, and I am the moderator of today's webinar. And I am in collaboration with many prestigious organizations such as World Health Organization, IMD, and so on, has been organizing webinar on every Tuesday between 11 a.m. to 1 p.m. on different aspects of disaster management. And today's webinar is a part of that series. Apart from webinar, NIDM also conducting online training program for all the stakeholders. On behalf of NIDM and IIT Guwahati, I welcome you all to today's webinar on hill area environment, climate change, sustainable development, and landslide risk reduction and resilience. There will be two sessions today, inaugural and technical one. For inaugural session, we have dignitaries, namely Major General Manoj Kumar Bindal, VSM, Executive Director, NIDM, and Professor T.G. Sitaram, Director, IIT Guwahati, and Professor Surya Prakash, Head, GMR Division, NIDM. Professor T.G. Sitaram, Director, IIT Guwahati, will also be joining us in technical session beside other experts, namely Professor Chandan Mahanta, Head Civil Engineering Department, IIT Guwahati, Dr. T.V. Bharat, Associate Professor, Department of Civil Engineering, IIT Guwahati, and Professor Surya Prakash, Head GMR Division, NIDM, and myself. The aim of today's webinar is to ponder on strategies to strengthen the resilience of our hilly areas against the recurring disaster due to climate change, and strategies to achieve sustainable development in our hilly terrains. As per estimation, mountain covers around 24% area of world's land surface, and about 12 to 14% population of world lives in and around hilly terrains. Earthquake, landslide, floods, flash flood, cloud bursts, and so on are among the major disasters that are frequent in hilly states and cause colossal damage to lives, livelihood, to our built environment, besides our natural ecosystem. Further, dramatically changes in climate conditions are anticipated to intensify the frequency and magnitude of these disasters. So we need to mainstream our risk reduction strategies, our climate change action plans in our each and every development activities, beside scaling up the skills and capacities of our communities for taking proper adaptation and mitigation measures in response to climate change. Hopefully, today's webinar will be fruitful in bringing out the roadmap in direction to achieve resilience for our hilly areas. There are some instructions to the participant. Attendance will be automatically generated, and 60% attendance at Cisco WebEx is compulsory to be eligible for the certificate. Interaction, discussion, question answer session will be after the presentations of all the speakers. I request participants for their active participation in technical session through their questions, which they can share through Q&A box. With these words, I would invite Professor Surya Prakash, Head GMR Division and NIDM, to enrich the participant on the theme of webinar through his opening remarks. Over to you, sir.
Thank you, Anilji. Good morning to all dignitaries, including Professor T.G. Sitaramji, Director, IIT Guwahati, professors and faculty members from Civil Engineering Department, IIT Guwahati, and all the delegates who have attended or who are participating in this program. I welcome you all on behalf of NIDM and on my personal behalf. We have been organizing a national webinar almost on every Tuesday between 11 a.m. to 1 p.m. since last about 4 months after the COVID has invaded our country, and there were no alternatives but to go for online platforms. So we had to stop our face-to-face training programs and meetings, and we started with online training programs and webinars right from the 9th April of this year. And this program is one of them in the series. We had organized various programs with the World Health Organizations, focusing on the various aspects of the pandemics. There were 5 such programs which we held. We held various programs with IMD, India Meteorological Department, with National Center on Seismology, with Geological Survey of India, with SASE, and many other prestigious national institutes as well as nodal institutes for early warning, mitigation, and response to disasters. Experts from all sectors were involved into this, and we carried out multidisciplinary cross-sectoral trainings for all levels, and we have also focused on communities at large. So now this is the specialized training which our specialized center on hill area development and disaster risk reduction has planned and is organizing today. We have collaborated in this particular training with IIT Guwahati, and this proposal actually came to us from none other than Shri P.P. Srivastav, a veteran bureaucrat who was earlier member of Northeastern Council and who proposed that the strengths of IIT Guwahati should be actually utilized in disaster risk reduction by NIDM together, and then the others beneficiaries from state disaster management authorities, district disaster management authorities, and line departments respectively from the hill areas can get benefited out of it. So we are thankful that we made a proposal to Director IIT Guwahati, and he has very happily agreed with our proposal, and today we are organizing this program. Thanks to you, sir, for accepting our proposal and participating in this program. And we are joined by the director himself, who will be following the giving the special address in the inaugural program. I'm sorry to say that because of other preoccupations, Executive Director NIDM may not be able to join with us in this inaugural program. So he has conveyed his best wishes for the program, and I hope the participants will try to make maximum benefits out of it by raising questions, relevant questions to our experts and speakers. Then only this program will be more useful. With these words, I welcome all in this program and thank you for this opportunity. Back to you, Anilji.
Thank you very much, sir, for enlightening the participant about today's webinar and about various initiatives of NIDMs. As sir had already mentioned that Major General Manoj Kumar Bindal, Executive Director NIDM, was supposed to join us, but due to some unavoidable assignments, he is not able to join, but he has sent his best wishes for the webinar. Now, I would like to invite Professor T.G. Sitaram, Director IIT Guwahati, for his special address. As sir is also one of the panelists of technical session, I would request him to take his talk right after his special address. During his talk, he will be discussing on slope stability analysis of highly jointed rock slopes on abutment of world's highest railway bridge across the Chenab River in Jammu and Kashmir. Over to you, sir.
NIDM officers and all the distinguished participants, and my colleagues, Professor Chandan Mahanta, Professor T.V. Bharat, ladies and gentlemen, thank you very much. We're happy to be part of this. As you all know, the northeast of India, with lots of hills and hill area environment, has been affected due to climate change, and lots lots and lots of landslides have occurred, even just few months back. Many of our colleagues are involved in the landslide assessment and also restoration works. I would like to just start off to tell you the earthquakes, landslides are basically hazards. They are not called disasters. They are hazards. These hazards becomes disaster when they come in contact with the human habitat, or when it affects the human habitat, they become disasters. So please, participants, note that whether it is earthquake, landslide, if it happens in the Greenland where there is nobody, it doesn't take any attention of anyone. When it happens maybe in a very densely populated area, these becomes very disaster, causing a lot of economical loss as well as human loss. So let me share you a brief presentation of my special address. I hope I will be able to see my presentation. Can you see my slides?
Yes, sir, it is visible, sir.
Yeah. So this topic is very, very relevant for the Northeast. That's why we immediately accepted Professor Surya Prakash's suggestion to have hill area environment, climate change, sustainable development, landslide risk reduction and resilience. Such a long title, very difficult topics are all involved in this. As you know, the environmental constraints, which includes very difficult topography, complex geological structure, adverse climate, and fragile ecology, most of the Indian hilltops, whether it is Himalayas, or it is Western Ghats, or it is Northeast. And particularly Northeast is much more, vulnerable because of it is in the zone 5 of earthquake zone, as well as heavy rainfall area. Okay, it receives a huge rainfall because highest rainfall here, city Cherrapunji is also located in the Northeast. Main objective of the hill area development program, of Government of India, many districts and cities have been identified, is basically eco-restoration, economic development, eco-development, and eco-preservation. So as you all discussing about climate change, I will tell you climate adaptation is a necessity and no longer an option for us. What is happening is this is almost reached extremes. The climate change has caused, whether it is rainfall, you may be hearing all kinds of news almost every day on the TV, whether it is floods, drought, or earthquakes, vibration, landslides, many hazards, which also cause a lot of disasters. So environmental sustainability is a fundamental to sustainable development. So we are the signatory for SDG goals with the United Nations, with all other countries. It was signed sometime in 2015. So we have, it's for 15 years. So we have almost close to 10 years left to implement the SDG goals. Let's look at, particularly we are looking at the hill area environment and the sustainable development. So landslides become a very key aspect. So we need to understand why the landslides occur, what are the impacts of these landslides on the people and the communities. As I told you, landslides becomes a disaster when it is closer to the community. So this is a very, very critical, and you can see India is full of a lot of variation in the ground levels, and you can see the elevations differences from zero mean sea level to very high mean sea above the ground. So this right-hand picture clearly highlights to you how our ground is very. India is very, very terrain-wise very complex, and other than the terrain, there are other issues which I highlighted to you. Technologically also, it will be quite different. So the natural phenomena that occur with or without human activity is the landslide, okay, which is a natural phenomenon. Basically, it's a gravity-related work. Gravity-related. Due to gravity, the soil would like to come down. There could be reasons: rainfall, induced earthquake, which is very prevalent and common. Earthquake-induced landslides are also very common. And the man-made is, we have created many disasters already by creating, cutting, undercutting and all that. But what is very important to look at it is the multi-hazard. Because now suddenly there could be rainfall, earthquake, and also man-made activities. So we need to look at the multi-hazard analysis of the landslides. So different types of landslides: falls, topples, slides, spreads, and flows. See, the causes of landslide, I just would like to touch upon very briefly. A landslide may occur because the strength of the material is weakened. And particularly, we are looking at soil. So located on a slope, the rock then no longer stronger enough to resist the forces because the surrounding soil has become weaker and forces of gravity act. So basically, it's driven by gravity, and during earthquakes, again, another moment of the due to earthquake also, it will also transform into force of gravity. Several factors can increase the slope's susceptibility to a landslide event, which is water. Is a very key. That's why geotechnical engineering becomes very important. Water, erosion processes, steepness of the slope, which we call slope angle, or the type of rocks, okay, and the shape of rock grains, jointing and orientation of bedding planes, if it is a jointed rock mass, arrangement of the rock layers, weathering processes, lack of vegetation, flooding, volcanoes, and earthquake activity nearby, as well as human activity like mining, trophic vibrations, or urbanization, which changes the surface water drainage patterns. So majority of recent landslides, what we are seeing is due to human activity, okay, because we are cutting the hill slopes for making roads, railway lines, and all that. So a lot of undercutting we are doing without proper taking care. If you adopt actually scientifically, we can make sure that this such kind of landslides doesn't happen. So just for the benefit of the webinar attendees, landslides are classified by the type of movement. The four main types of movements are falls, topples, slides, which are rotational or translational flows. So, as I told you, landslide hazard, it turns into a disaster when it comes in contact with human habitat. Okay? Landslides encompasses all categories of gravity-related slope failures in earth materials. It could be soil, it could be sand, it could be clay, it could be rocks or jointed rocks as well. But please remember one thing: the slopes, they appear stable. They're not stable. Always the slopes are actually a dynamic evolving system. Because if you know, Mother Earth also vibrates. So these vibrations, these slopes are also constantly, under dynamic movement. Okay, any slope for that matter. See, it is under constant. You may not be visible to you. It looks stable to you. It looks static to you, but it is constantly a dynamically evolving system. Material is constantly moving on the slopes at rates varying from imperceptible creep, that means you may not be visible to your eyes, or to thundering avalanches and rock falls moving at very high velocities. So slope does not need to be very steep for a landslide to occur. That is what you have to understand. So landslide means it is not just a very steep slope, only hill slopes can come down. No. Slopes can be very gentle also, but landslide can occur. Okay, that's one thing you need to carry as a message. So landslide is a very complex topic because the area where it occurs is not known to you. Sometimes even the known landslides can recur the movement. As I told you, this is a dynamic evolving system, so it's difficult to predict. So that's the reason that makes it much more complicated. So landslide susceptibility, landslide observations or observatory, landslide modeling, and landslide monitoring is a continuous ongoing process to understand each of the landslides. Okay? Many landslides have caused a lot of hazards. So we look at this as a multi-hazard problem, because so a heavy rainfall can come together with an earthquake, or heavy rainfall can come with a human activity of cutting slopes. Heavy, due to an earthquake and human activity also. So it's a multi-hazard problem. So we need to look at this problem much more carefully. So with these few words, I would like to say this is a very important topic for India, and also particularly to the Northeast. And as I told you recently, our group, I think some of them may be presenting today, that where our governor of Assam lives, it's a hill which is a known landslide area, which started moving when recent heavy rainfall occurred in the monsoon. And similarly, there were several landslides on the national highway which are closer to IIT Guwahati. So this is a very common phenomenon in the Northeast. And if you look at the ranges, whether it is Meghalaya or it is Nagaland or Manipur, Tripura, all of them, all the 7 states are very vulnerable for the landslides as well as earthquakes. So multi-hazard analysis is a very important, and we need to look at that as a very comprehensive analysis with proper susceptibility analysis and proper observations, and including rigorous modeling with continuous monitoring of these landslides. So with this, I would like to congratulate NIDM for taking up such an important topic and spreading the awareness on the topic of landslides. These few words, I would like to conclude my special address and leave it to the organizer, and then take up my talk after that. Thank you. Namaskar. Yeah. So if you want me to go ahead with my talk, I will go ahead.
Carry forward to your talk.
Okay, thank you. Can you see my slides?
Yes, sir.
Today topic, I have chosen is the one, it's not about landslides, but it is making sure that landslides are not going to affect our major infrastructure projects. This is the topic. What I've chosen is slope stability analysis of highly jointed rock slopes in the Himalayas, and the abutments of the world's highest railway bridge across the Chenab River in Jammu and Kashmir state, which is a very important project for India, which connects Kashmir to the mainland. So I am associated with this project since 2005, early January, and still it is not completed. Maybe next year, by next October, the entire bridge will be ready to go. For the people who want to know where is this project is about 50 to 60 kilometers away from Katra. Katra is a very well-known Hindu religious place. Vaishno Devi temple is there. Okay, from there is about 60 kilometers. So as you all know that recently 2016 or 17, Honorable Prime Minister inaugurated Udhampur to Katra railway line. So now people can directly go to Katra, get down and have a darshan of Lord Vaishno Devi and come back. Okay, so large number of tourists go there, and now from Katra to further north it goes. I will show you the location of the. So I am involved with this project 2005 to 2020. So the major challenge was here is the slopes. Please understand, from 2005 to 2000, almost 19, is only about stabilizing and cutting the slopes. And 2019, maybe middle, they started the superstructure. It is almost getting ready. It's one of the largest, highest elevated bridge in the world. I'll just show you the pictures also. So this is the Chenab Bridge location. Okay. As I told you already, it's about 50 to 60 kilometers from the Katra town. And I did a first visit in 2005. And in 2007, a lot of deliberation to change the alignment. Why did the change of alignment came into picture? Because it's only landslide. Because they thought that these hills are not stable. So every expert, see, there were at least, I myself have seen 10 experts from 10 different countries, including top-notch experts of rock mechanics and rock engineering in the world who are there. And we had so many deliberations. I was representing Messrs. Afghan's construction, and there were experts also from other IITs and other places for the railways, because this project, even though belongs to Northern Railway, was executed by the Konkan Railways. Okay, Konkan Railways is the sort of running this project, sitting in Jammu. And what is important is before the construction of the project, you see, this is the river Chenab in the center, and we need to connect the other two sides of the. This is access roads to both the abutments was also the key. You see, you might see many access roads for the many abutments and the bridge pillar foundations. So right now, as I told you, bridge deck and arch are almost under completion. Okay, so the entire final foundations were almost completed end of 2018 and even went up to even middle of 2019. This is going to be the world's highest railway bridge once constructed. This connects Udhampur, Srinagar, Baramulla rail link project. See, all of you know that Srinagar to Baramulla already rail line is moving. So we crossed using the road and taken the railway lines as well as rail bogies there and started operating from Baramulla to Srinagar. So now we need to bring Srinagar to Udhampur connection. This is in Himalayas, active young mountains of the world, sub-zero temperatures, difficult to access, and also you know the disturbances. I don't need to highlight too much about the disturbances. So there is new technology and new innovations every step of the construction of this bridge, and particularly, as I told you, almost 2005 to 2019, that means 15 years, close to 15 years, is only the construction of the embankment, the abutment slopes, cutting slopes, putting the foundation, taking the pillars. So this, the location is, I can show you. So the Riasi is right here. Okay, this is basically somewhere here. See Udhampur, and Katra is somewhere there, and Riasi, and then connects to the northern part of Srinagar, and then, as I told you, Baramulla. This line is already operational. Srinagar to Baramulla is already a railway line is operational. This one shows the much more closer one. You see, Srinagar to Baramulla line is operational. Kazigan's Banihal to Kazigan, Kazigan to Srinagar is also operational. Okay, this is a railway line which is already operational. And now Udhampur to Katra, as I told you, was recently inaugurated. So Katra, this is the Riasi which I showed you in the previous slide. So Riasi is here. So Katra to Banihal is the stretch which is under construction, which is 111 kilometers long because of the circuitous route. And the bridge, Chenab Bridge, is across Chenab River, which is flowing there, and that is the location of the Chenab Bridge. You understood now? I think the location is very clear there. So what we have adopted is the very interactive design. What we call it's also an observational method as per the International Society of Soil Mechanics and Geotechnical Engineering. There is a special committee called TC206, which looks at the interactive design, which is currently very unclear or undefined. It's a new committee which is looking at what is this interactive design. So I will highlight to you soon what is this interactive design in geotechnical engineering. That this has become a very common now. It appears to be same as observational method, but it is not, which has a body of references. This observational method is very quite common in tunneling. Okay? In tunneling, you excavate, observe, and then adopt a newer design methodology for the next section when you are before excavating. So it has a body of references and already referred to in guides and codes and Euro codes, as well talks about observational method. But what today I'm going to talk to you is what is called as interactive design. Interactive geotechnical design is a design approach that requires a design refinement throughout the project execution period until a suitable technique and an optimum scheme are applied to the problem at hand. In general, use of interactive geotechnical design is not a frequent. However, in large project, it has to be an iterative one. That is why this interactive design plays an important role in many of the large projects, whether it is highways, airports, tunnels, and railway lines. Okay, we learn more about the ground realities and design is modified or updated and move ahead. In mountainous terrain, it's very, very critical. This interactive design plays a major role. And particularly in the stabilization of slope, it is inevitable, like in highways, railways, power generation, mining, residential building projects. In all these cases, depending on the importance of the project and the consequence of failure, elaborate geotechnical and geological investigations are required. But these geological and geotechnical investigations are not done once. They are done many stages and many phases. And the slope stabilization measures are also has to be iterative. And it has to be iterative and implemented in iterative manner. So what I termed it as, okay, this is a completely a new topic. Okay, we termed it as because as I told you, we had 15 years of this only one project and several engineers, and Afghans is very proud of this project. We called it a design as you go project. Actually, several PhDs have come out of this. Okay, several, both at the Institute of Science, as well as right now one of the senior most vice president of the Afghans infrastructure is also working on at ISM Dhanbad. So it's called interactive geotechnical design, which establishes guidelines and technical recommendation within the TC206 is the committee which is looking at it. So recently I gave a talk also to them. So let me define the problem to you. Highly jointed rock mass is predominant in the Himalayan regions, where the ground was subjected to severe tectonic activity due to pushing of the Gondwana land into the Eurasian plate. As you know, Indo-Australian plate, which is what India is located in. So this Indian plate is pushing the Eurasian plate at a rate of 50 millimeter per every year. That means Himalayas is rising every day. Okay, please understand this is a movement is common. So when you look at the stability aspects, that means this movement is also has to be considered, because this is not a small movement. The seismic activity is also still very present. This is a plate boundary between the Eurasian plate and the Indian plate. So what is the problem is, because of this, these rock masses are also highly jointed which is close to almost like a soil from strength point of view, but at the behavior point of view, it is still a jointed characteristics. So this is geologically, this rock is called as Anger dolomitic, which is basically an Anger limestone. So the analysis of the slopes, see, one of the other problem with limestone or the dolomitic is there could be huge cavities and caverns, which are maybe you are aware of it. So huge means I'm talking about 3-4 times the height of a man. That means 30 meters open cavity, which is existing and stable inside with the stalagmites, stalagmites, and all that features which are observed in a limestone caverns are also possible in Anger dolomitic. the analysis of the slopes and assessment of safe bearing capacity of these foundations. So the problem was this bridge is going to be one of the world's best. Structural engineers felt that this is going to cause a lot of instability to the slopes. So that too, it is a railway bridge. So due to vibrations coming due to the movement of the trains also can cause a problem, and it needs to be evaluated. So you can now see the importance of it. 10 to 15 years we are working on this problem. So the bearing capacity of the foundations on these slopes are also very challenging to find out. Because I'll tell you, we had discussed almost 2 years with several, maybe more than 10 meetings, including a highest technical advisory board tab sitting in just to discuss on what would be the allowable safe bearing pressure for the foundations on these dolomitic rock slopes. Analysis becomes very cumbersome and also expensive. So we have, because we can't model that this is a discrete material of jointed rock mass, it has to be modeled as a continuum. So let me take you through objectives. Our objectives, which was posed to me by the company, was determine the intact rock and rock mass parameters for the analysis and design of slopes in jointed rock mass, suggestion of the appropriate parameter based on the detailed geotechnical investigation for the design of the slopes, determine the stability of slopes and suggestions, appropriate stability analysis and stabilization methods, and lay down the principle of design as you go and bring out the data methodology, implementation of developed methodology. Not only that, every section which is constructed, we have to go and visit. So I might have visited maybe about 25 to maybe almost 30, 35 times gone to that location. Very difficult to reach that location, but that is a different experience. Once you saw pictures, you will see. So let me give you about the bridge. So as I told you, the Chenab Bridge is once again crossing the Chenab Bridge, Chenab River, right there. Okay, it is between Katra to Banihal, and this is the bridge. So the deck is about 362 meters above the riverbed level of Chenab to the top of the deck, and this is a complete one single arch for a width of about almost like 780 meters. And total length of the is more than 1.4 kilometers. And this is the approach viaduct portion. Please note that these are all tall pillars. Okay, and the bridge is a steel bridge. It is taller than the Eiffel Tower. So this is how the slopes were cut, and even this design of what is the slope profile to be used also. Several discussions happened. So initially we thought that we can go and put the pillar through a drilling machine taken through an helicopter and then drill and put the pile foundations. All options were discussed, deliberated, analyzed, and finally this is the cross section which has been adopted. Okay? This is from the left side from S10 to S40, and the other side from S50 to S80. And this is where S50 foundation anchored through the arch, and these are the columns. Okay, S50, S60, S70, S80, and it goes up to S190 in the valley. Okay, so you can see before excavation how was the terrain, and after excavation. To do all this, we need to cut a lot of slopes to make roads, to access roads, so that construction equipment can move. And whatever in this project is done, everything is world record, okay, including the crane, what they have put here. This is also Guinness Book of Records. They have entered into. Everything is something which is beyond the imagination, okay. And the kind of cuttings which we have done is a huge rock cutting and unimaginable. So the first question was, is this site stable? So many, we have went through by foot and went through by boat and looked at many landslides were there. But the correct site where we have looked at 2 kilometers on the downstream, 2 kilometers upstream of this location where the site was chosen, never had any landslides. Okay. Otherwise, after beyond 2 kilometers, there could be a lot of slopes, slips occurred. So you can see this is the S40 foundation, S30 foundation, S20, S10 foundation. So you can see this is a 215 meter tall. This is on the one side of the abutment. Okay, and look at how much quantity, 3.15 lakhs cubic meter of excavation. And this doesn't include the road construction excavation done for that. Okay, this is only for this slope. This is on the other side, 124 meter. Shotcreting is 15,400 square kilometer. This is on the S50, S60, S70, S80. The kind of rock bolts we have used, the Davidic bars installation in slope. And this is one of the typical examples of the rock bolts which you have shown. Double corrosion protection rock bolts were used, and every code, because we didn't have a proper code also in India, so all the BS standards were used for because this was the requirement of the railways. The field investigations, see, this was the initial slopes. You can see these are all some of the cut slopes for the access road. So we have to cut a lot of access roads to make to the this is the location of the bridge. Finally, this is the location of the bridge. And for particularly in one side, soon after the bridge, it enters into a tunnel. Okay, and so this will be a very unique, and also the wind speed is very, very high. Okay, so geological logging, I even suggested to them. This is what myself and Professor Ramamurthy of IIT Delhi suggested. We should have a audit tunnel just above the foundations. So that means this will be, when it is excavated, this will be vanishing. So this will be excavated now. Okay, so this was above the foundation level at S50. Similarly at S40, this is the location what you can see. So we have drilled about almost 300 meters and then went in on the laterally also another 150 meters on either side. A lot of tests were done. We can visualize what kind of rock, what kind of joints, was there any slip failures, and all that. So geological logging of these drifts were done. Okay, and also there were outside the drifts, open area pits are also done. So a lot of lagging. So we could see many joints, J1, J2, J3, J4, and in some places more than these set 4 joints, but 4 joints are very prevalent. Okay, so this is the pit which has been mapped, joint locations. So you can see the final geological of the main and of the drifts. So just to summarize, highly fractured dolomite, joint spacing is between 20 millimeter to 500 millimeter, joints filled with silty sand and silty gravel, presence of open joints. I will take 5 more minutes to complete. RQD 0 to 10, RMR 35 to 42, ECS 16 to 62 megapascals. Permeability is more than 50 lugans. There is no groundwater at all. Okay, so which is a very complex site. So I will not get into the details. Some of you are interested. A lot of geotechnical testing over a period of time, and also several phases we have done. Plate load test, in situ box shear test, borehole data. Based on the borehole data, RQD, UCS, RMR was also done. Settlement characteristics like shear wave velocity, tomography is also done. Dilatometer test, plate meter, borehole data, lots of tests. Okay, so summary of these parameters and what to select also for the analysis was also a great challenge. Many discussions with the technical advisory board, and several parameters were selected, several variations were done, and minimum parameters were chosen for the analysis. Then coming to the earthquake, this is the area, even though we say it is zone 5, we never have, India doesn't have a record of any strong earthquakes. Okay, so we have not recorded properly yet, because only it is all done in the last 20-30 years only. So there are not much major earthquakes. But what we have designed is the maximum credible of 0.36 G, and design basis across 0.1 DG. We have taken both the vertical as well as horizontal component of these accelerations on the slopes. So analysis slopes. So the railways have asked, we need a minimum factor of safety of 1.5 with static load after the excavation and putting the treatment. And the static loads and DBE seismic loads is 1.2. Static loads with maximum credible earthquake seismic loads is 1. Pore water pressure, though there is no groundwater, you should take some pore water pressure. That was the recommendation. RU factor of 0.3 was considered. And differential settlement allowed was only 20 millimeter. 20 millimeter. Please note that that's a very important design parameter. So numerical programs, analytical was used. Many of them, we have done, as I told you, 3-4 PhDs are done at Institute of Science. And right now also one PhD is going on. So average dip direction dips we have used, Swedge continuum approach we have used, flat and slide we have used, and also Itasca, which is a University of Minnesota's company, have also done using 3-deck. So anyway, I will skip some of these analysis data. You can see the pictures. If you have any questions, you can ask me. So this is a completely what finally, from our detailed analysis of more than 10 years and a lot of PhD thesis, what we found is the bridge is like an ant over the elephant. These slopes are so huge. There could be some slips and other things locally, but globally, this bridge is not going to change any scenario because these are moving slopes anyway. So putting the bridge is not going to change any scenario. So I even termed it and put it in front of the very high profile committee, said ant over the elephant. It's as simple as that. So that means that the elephant even doesn't feel the ant. Okay, so the continuum analysis, so it's a lot of analysis. I'll tell you, I don't like, because as I told you, 4 PhDs are completed. So it's very difficult. So all the displacement, relative displacement was kept less than 20 millimeters. So our strengthening measures, rock bolting, and done in stages, excavation, all that is fantastically done. Okay, so the dynamic and the differential settlement and differential lateral displacements are also considered. So under dynamic loading also we have done static loading, and quasi-static analysis were also conducted. So what finally said, under dynamic loading, the predicted displacements are towards the right side into the hillock and hence not endangering the slope. So then safe bearing capacity, you see, safe bearing capacity, you see, the problem is, because they are all on the slope, one side of the resistance will never come in. So there is no proper guidelines. So ledge resistance is the only guideline in the building, in the Bureau of Indian Standard Codes. So we have taken that guidelines and designed. And finally, we have pressed the assessed bearing capacity. I will show you some of the bearing capacity analysis, and because we have done slope stability also to evaluate our self-bearing pressures. So when I found that the bearing pressures are also look at 424 to about 1,000 ton per meter square, at different location of the foundations, right? So 230 was the lowest. But what did we use? Look at from the slope stability analysis also, we get consistently more than 200 ton per meter square. But what is the finally recommended? Only 100. And this was again discussed with the railways. They have adopted only 90 ton per meter square. So you can see how much. Why 90? Sir, where was the logic? It is based on RQD. But RQD is such a crude test. RQD was the only one which gave the lowest, 87.4. But rest of all techniques, we gave a very beautiful, high value of the safe, reliable bearing pressure. Anyway, I will conclude, as I told you, promised you. So kinematic analysis was also done, and predominantly we see some wedge failures locally. So that is why we have adopted a lot of rock bolting using diabetic bars and other things. So wedge failure analysis was done very methodically after every excavation, so that we do not have faced any failures. So we never had any failures. So static load case, dynamic load case, and quasi-static load case all analyzed. And then this continuous analysis was done, as I told you, on both sides for excavating. And then safe bearing capacity was adopted, as I told you, about 90 ton per meter square. And then assessment of slope mass rating. And see, I will tell you, whatever methodologies available in literature, all have been tried and attempted and demonstrated for this project. Just to give you a last one slide on challenge is the excavation of slopes. Unstable slopes coupled with difficulty to access. See, we have to, one side, 2.5 kilometers of approach road you have to make. So thanks to many of the railway engineers, it's a very hard job. And every day moving on the roads is a nightmare. Why? Because at least whenever I have gone, I used to close my eyes and sit, because you can't see the right side or while coming the left side. It's very, very scary, because it's almost like 300 meters up. Suddenly there are no curbstones, nothing. And roads are also not properly made, and it's all constructed. During construction, we were moving there. So this making approach roads only will take a lot of time and a lot of analysis. And the excavated slopes were shotcreted, and use the very high technology materials. As I told you, cleaning is also done very methodically. Congratulations to Afghans. And these are the kind of rock bolts, fabricated rock bolts you can see. Okay, and the high technology equipments are used, and many times this is the kind of drilling equipments are also very state of the art. Everything was state of the art. Okay, because we are building world's best. So the key to success in discipline: strictly follow the contours during excavation, strictly follow the top-down construction, design as you go, validate the design assumptions as the excavation progresses, a lot of testing using sophisticated equipment with robotic controls and high-end things were done. And then to conclude, the kinematic analysis indicated predominantly wedge failure locally, and but otherwise total slope was perfectly stable. And even today, I can guarantee you, because as I told you, the bridge is going to put very, very small load, even though for structural engineer, this is one of the highest elevated bridge and one of the complicated bridge with earthquake and land and wind load. Large loads are coming, but to me, for my slope, the entire bridge with all the wind load and earthquake load is a ant or an elephant. With this, I thank you very much. And this would be the final bridge. When it comes, it looks like this. Thank you. If you have any specific question, I will take. I'm closing.
Thank you for highlighting Chenab Bridge project and briefing about interactive design or observatory method Himalayas. Sir, one of our participants, Mr. Hemant Kumar, asked one question: is this continent or subduction also affect landslide?
Again, repeat the question, please.
Is this continental drifting or subduction also affect landslides occurrence?
Definitely. See, as I told you, slopes are all moving. I told you, because there will be a movement of the landslide mass itself. So it's a gravity effect. So definitely it will be aided by rainfall and earthquakes further. Okay. Or human activity like vibrations caused or anything. It will be accelerated. But otherwise also, landslides are continuously, these slopes are continuously under the movement. Thank you.
Thank you very much, sir.
Thank you.
For our next presentation, we have with us Professor Chandan Mahanta, Head Civil Engineering Department, IIT Guwahati, and Dr. TV Bharat, Associate Professor, Department of Engineering, IIT Guwahati, who will share their experience and knowledge on the topic of impact of climate change on the stability analysis of slope in Northeast India on the regional and local scale. I will request all the participants to raise their question in the Q&A window. The floor is over to you, sir.
I don't see Professor Mahanta here. So is Professor Mahanta here?
Sir, I cannot see him in the panelist list, sir. Anil, sir, you want to say something, sir?
I think he didn't join us.
Otherwise, should I start? Then perhaps you can.
Yes, sir, you can start.
Yes. I hope you are able to see my presentation.
Yes, sir.
Distinguished delegates, distinguished NIDM members, officers, and our director, sir, Professor T.G. Sitaram, and Professor Mahanta, and other distinguished participants. A very good morning to all of you. So today I'm going to present on the impact of climate change on the stability analysis of slopes in Northeast India on a regional and local scale. So Professor Mahanta will talk about the regional scale aspects, and I would present some recent landslides that have occurred during the monsoon, as Professor Sitaram sir has mentioned recently, some time back. As we all see, the climate change has a great impact on the stability of natural and man-made slopes and have consequences on landslide occurrences. However, the interrelationship between the climate changes and landslides remains difficult to determine and to predict the landslide occurrences. So this was by Guwahati and Guwahati in 2016, but this is still valid. So this presentation will do a brief attempt to understand some of the recent landslides in and around Guwahati area. So this is the Guwahati area. You see the Brahmaputra river flowing, and we have northern side of Guwahati, where our IIT Guwahati is located, and there are green patches where there are several hills present, and the land use is also mentioned in this particular map. If we focus on the striking geomorphological features, such as 9 hill series that are situated in and around Guwahati area. There are also low-lying alluvial plains and marshy wetlands. The important hill series which are useful for the present presentation are this Navagraha Sunsali Nunmati hill series, which is on the southern bank of Brahmaputra river, and Agyaturi 0.9 on the northern bank of northern side of Brahmaputra river. Our IIT is situated next to this Agyaturi, and in between the Agyaturi hill series and the Brahmaputra river. And the Nilachal hill, that is 5th one, where the Mahakamakhya Mandir is situated. And from IIT Guwahati campus, we see the Nilachal. Currently from my window, I can see the Nilachal hill. So this is the geomorphological features of Guwahati. And these all hilly areas which are susceptible to rainfall induced landslides, because even though they are of comprised of granite gneiss complex, however they are capped with residual soil formed due to the disintegration or weathering of in situ soils. So all of them have this red soil formation due to the vegetation and weathering process. So these two, I'm focusing on Agyaturi and Navagraha Sunsali Nunmati hill series, because there are several landslides occurred in the month of June 2020, very recently, a few months ago. So this is very close to IIT Guwahati, Agyaturi hill series, and other one is right across the other bank. So let me go through some of the landslides at the local scale. So this is on the Nunmati, Navagraha Sunsali Nunmati hill series. We also call Karguli Hills. On the Karguli Hills, this is the Raj Bhavan, where governor's building is situated, and there is a landslide that has occurred on 24th June 2020. If you have a closer look of the landslide, there is a mud flow that has taken place. So I'll come to that, why there's a mud flow that would have taken place here. And there is another landslide that has taken place after 2 days from the previous landslide, that is on 26th June 2020 near IIT Guwahati. This is also called Kali Pahad. This is part of the Agyaturi hill series. So along this, there is a NH national highway. This is a 4-lane road, by the way. Entire 4-lane road is completely buried with the debris, which consists of huge boulders. So if you compare the earlier landslide and this landslide, there's a huge difference. Earlier there was a mud flow that has taken place. Here there were boulders that have gone down under the gravity. even though the landslide has taken place nearly at the same time, it's only 2 days difference. And there is another landslide that has taken place on the same hill where the same hill series where the Raj Bhavan is located, that is the Kargil Hills, on 28th June. All these 3 landslides are with a 2 days interval. So here debris has actually in fact flown into one of the residential areas, and it has killed some people, and one of them is a young budding artist from Guwahati. And here also there is a debris flow, and also mostly this is a very soft soil, soft residual soil that has flown down. And it is noteworthy to say that from the source that I have collected, the rainfall data, the rainfall precipitation for the month of June is highest compared to our last 10 years. And that would have caused landslides. But if you observe daily rainfall data, the striking observation is that there were 2 peaks. One peak is, this is day 0 to 30 in the month of June. So therefore on the day June 6th, there is one peak, and nearly June 16, 17, there is another peak. These 2 peaks are higher compared to the 3rd peak. But most of these 3 landslides occurred during this particular time interval, which also throws some light on first of all, the climate change effects definitely has influence on the landslide occurrence, but also the in situ characteristics of the soil. The in situ conditions of the soil also play an important role. That is the reason why the Raj Bhavan landslide, if you see the history of the landslide, there was already a landslide that has taken place 2-3 years ago. This is a repetition. Therefore, there was a mud flow that has taken place. However, for Jaiguru landslide, this is the first of its occurrence, and therefore there's a huge debris flow that has taken place, and huge rock mass have come down. There are other local soil characteristics or features that will be explained in a minute. And similarly, Kargil landslides, there are several landslides that have taken place in the past, and that has occurred after the peak has receded. So, however, we don't have the field characteristics or the soil characteristics at the in situ. Due to the pandemic, we couldn't visit many of these places. However, based on our experience from another landslides in the previous year, that is 2019 June, in Shillong, that is a Meghalaya plateau, that has occurred. From that, we got a lot of information from that particular landslide. So I'll be presenting some of the initial in situ characteristics of the soils, how they play an important role in the landslide occurrence. So this is in Nehu, Northeast Hill University, Shillong. There is a Sports Authority of India complex, Sai campus, which is situated on a hilly area. On the left hand side, you see a plain ground, but that is made flat. However, there was a very gentle slope of a hill that was existing earlier. So they made an athletic track. So here the landslide location is shown here, and if the right hand side picture shows the landslide location. There was abutment wall they have constructed on the hill slope, which however given more weight on the hilly area, and then which also failed during the landslide. This occurred on the 27th June of 2019. So this we have analyzed, and we have the precipitation data from 1st June to 15th July, and the rainfall precipitation was highest on the 27th June, and in fact the failure also occurred on the same day. However, the initial conditions, that is the initial moisture that is present in the slope, will also play an important role. So these are some of the controlling factors at local scale. So initial wetting conditions of the slope, soil field density, slope angle, vegetation, etc., and unsaturated soil characteristics. From regional scale, however, we understand that some features only we can capture. Sometimes the soil moisture also we can capture. However, at the local scale, some of these soil characteristics are so important for predicting the rainfall events. The global index, rainfall landslide index, can give you a feel for landslide occurrence or vulnerable areas. However, the specific information about soil characteristics, unsaturated soil characteristics, and other information shown here can provide the exact occurrence of the rainfall-induced landslides. So even though we, after the rainfall, after the landslide, we have visited the place, we could not get the moisture profile, moisture content within the slope because it was not monitored before. So we simulated for over a year, about 10 months rainfall data we have taken, and then we have simulated the transient flow through the transient flow analysis, and we got we can say that the factor of safety was much higher than 1, and it is safe, and we could get the moisture profiles within the slope. And another important characteristics is unsaturated soil characteristics. These are the constitutive relationships such as water content. On the left hand side, you see water content versus suction. The suction is nothing but which is coming from the surface tension at the air-water interface. Soil has additional strength compared to when it's dry or completely wet. This additional strength is shown on the right-hand side bottom figure, where the shear strength you should come from right to left. As the matrix suction decreases, that means the additional strength coming from the surface tension is decreasing due to saturation. The shear strength is slightly initially increased and increased to peak value near 100, and then after that it starts decreasing. This is what happens when the rainfall occurrence takes place and moisture flows into the slope, and then above figure, which gives you relative hydraulic conductivity and matrix suction, where you see again near the 100, which reaches nearly saturation, and then the suction value also decreases, and which reduces the hydraulic conductivity as well as it reduces the shear strength of the soil. So initially, when the slope is dry, it has additional strength from the drying aspect, from the surface tension aspect. That additional strength has been lost during the rainfall event. So therefore, the amount of rainfall that is precipitated, which infiltrates into the ground, also plays an important role in understanding how shear strength is decreasing. So we have conducted several other experiments in the laboratory to determine these characteristics in unsaturated states, and we in fact could predict the failure surface very accurately, and also we could predict the failure that has occurred on 27th June accurately. So such things are possible only when we have the detailed analysis can be carried out when the soil characteristics at the local site are available. Now this is, I just want to conclude from here that the harsh climate change is severely detrimental in the occurrence of landslide and also prediction of landslides, and the local scale effects such as unsaturated soil characteristics, field density, soil rock conditions, vegetation, initial moisture content also play vital role in the occurrence of landslide and cannot be ignored apart from the regional scale aspects. Now this is over to you, sir, Professor Mahanta. Sir, I started my presentation before you, Professor Mahanta.
Hello, everybody. I'm so sorry. I think I got into the participant group, so I didn't have any control on my audio and video. Then I requested the host to connect me there, and I'm now connected. I don't know how much time we have. If we have some time, I can bring a couple of slides. Otherwise, I can give a summary. Primarily because you have listened to both of my esteemed colleagues, Professor Sitaram and also Professor Bharat. And the point that I hope has settled down is the kind of extensive and intensive work that involves. If you have listened to, I noted down the presentation made by Professor Sitaram, that the kind of, extensive and intensive work that goes into one single project, On the other hand, the three slides that Dr. Bharat have presented, we worked as a team, and two of them are just within a couple of kilometers from our IIT campus, and the other one is about 1.5 hours drive from Guwahati in Shillong. There also you might have seen the kind of detailing that is necessary. Now the problem is that the Northeast actually is a sort of a natural laboratory for not only landslide but all kind of hazards, and we almost live with these hazards on a day-to-day basis, as has been very brightly pointed out by Professor Sitaram also, that the landslides are dynamic processes, dynamic events, but at the same time we are also having this dynamic stuff on a dynamic landscape. So if you look at, if I can quickly talk about the factors, the kind of study and investigation that we do, the kind of mitigation and management, and sort of what perhaps National Disaster Management Institute can think of for future intervention. Firstly, that we are living on a tectonic plate margin have been already maintained. And so there are, endless slides happening because of the tectonic movement itself. You'll be surprised that some of these slides, natural slides, which are more of hazard, not disaster, because these are happening maybe beyond human settlements, are sometimes hundreds of meters, even beyond kilometers. So you can imagine one slide kind of bringing in debris, and sort of we not have any kind of response to those. And fortunately, no human settlement. We don't really bother much about those. Interior Himalayas, in the Tibetan Plateau and all that. On the other hand, in the hilly state, particularly because your focus is on hill terrain, we have Arunachal, particularly right now because of the Trans-Arunachal Highway, and a lot of infrastructure happening. There are a series of disturbances, and obviously the slopes are getting disturbed by human intervention. And we are almost kind of, having our hands full at IIT Guwahati. Before we handle a slide, we are called for another, we are called for another. And as you can understand, with the kind of intensive and extensive work that involves in each of the slides, it's almost impossible for us to, kind of get into all of them. So starting from the tectonics and the resultant earthquake landscape, Northeast is full of landslides, and not to talk about, earthquake itself is a hazard and a disaster. And also resultantly, because these landslides are generating millions of tons of sediment, they're creating a different kind of problem in the tributaries and the river like Brahmaputra, where you have a huge problem of sediment deposition and bank erosion and flooding and spilling over, creating problem for navigation channel, etc. So tectonics and earthquake are two things we have not much control over. We can only adapt to it. We can only think of mitigating. We can only think of doing our design structurally to fit into that. The third factor that creates a bigger problem here is the heavy rainfall. You must be knowing that the highest rainfall area of the globe is located in the Cherrapunji and Mausinram area, and the entire Northeast have a huge rainfall. Not only that, the theme that you have as a climate change today, there are intensified episodic rainfall even happening, including a lot of cloudbursts that frequency apparently have been reportedly gone up. So these rainfall and the cloudbursts in particular suddenly brings down the kind of material from the slope, not only inducing the slope failure as a triggering factor of pore water pressure enhanced by rainfall, also the kind of debris that comes down becomes slurry, and a lot of different kind of slow and rapid movement happen. And you can talk to some of our colleagues in National Highway Authority of India and the Railways Department who are building the roads, railways, and the tunnels in the Northeast, the kind of challenges that they are facing right away. So clearly, the huge kind of overdue infrastructure initiative in the Northeast, both plains and hills, have again sort of undesirably perhaps accelerated the intervention in the natural slope, and it has actually enhanced the challenge of landslide in particular, but also other hazards which are like secondary and tertiary result of that. And to top of it, you have the climate change coming in, which is actually intensifying rainfall, and as a result of that intensifying slope failure, intensifying material and debris coming down and clogging our drainage basins, and I mean, it's sort of mind-boggling, and as has been maintained, we are kind of perhaps looking at every single thing that is available in a textbook to utilize and apply in the field to solve some of these problems. Now, what sort of, steps we can have in terms of study and investigation? Today, fortunately, our remote sensing tools have gone up enormously in terms of its capacity. We have a lot of good digital signature of even minutest movement and also resultant, material characterization, stuff like that. So we're doing a lot of remote sensing map-based study, particularly because in the Northeast, many areas are inaccessible. Many areas are beyond reach, but then problems are happening. There are sometimes small villages where a couple of families are there. So once we have a good remote sensing tool in hand to decipher and look at some of the locational issues, the example that Dr. Bharat has given, the Raj Bhavan, we have just got 2 days back the entire report of the geophysical investigation done. That is, after the remote sensing study, we have done all sort of tomography and resistivity and other surveys and seismological survey to know the detail of the behavior of the hill and the slope. That report has come. We are going through that report, and based on that, we'll be also carrying out a lot of specific geotechnical investigation, collecting sample from boreholes, doing cross boreholing, as have been already very elaborately illustrated by our Honorable Director, Professor Sitaram, that what has happened to that bridge perhaps was one of the extreme examples. But what you will be doing here may be at a little smaller scale, but we'll be doing a range of geophysical and geotechnical investigation linked to the remote sensing study. And not to forget that these are already kind of mostly facilitated by hydrological condition. We also have to do a lot of hydrological studies, the rainfall on that particular location. I mean, for that matter, any landslide location, then the infiltration, the whole sort of piping, the infiltration, the soil conduit, and all that. And finally, of course, we cannot today help without doing a societal study that who are the people, what are their cultural behavior, how much risk prone they are. Right now, the Raj Bhavan here, landslide has resulted into closing down of a big nursing home, one of the oldest nursing home of the Guwahati city, because the material, the slurry have entirely gone to the hospital premises, and the nursing home was under threat of getting buried by some of these material getting dislodged by that particular slide. We have actually now tried that during winter, hopefully we'll have some control because the rain will be gone, and we're thinking of creating some sort of protection so that the nursing home at the pandemic time, being of very crucial importance, can be made operational again. There are a lot of societal issues involving that. Newspaper reports are coming. How come the Raj Bhavan, slope failure is now creating bigger problem for health services, etc., etc. You can understand the kind of pressure also we have got into, solving this problem, and our hands are full. We are academicians, we have classes, we have research, but at the same time, I think this particular webinar and the workshop could not have come at a more appropriate time, because we are just talking about establishing a disaster resilience and management and sort of risk reduction center at IIT Guwahati. I'm sure NDMI will have a future possibility of partnering with this center to take ahead some of their initiatives in the Northeast. So what we do in terms of mitigation and management after the investigation, you have seen the scale issue is very enormous. There is a whole big slides which are very difficult to handle. But the smaller one, the urban one, the intervention that we have seen, that slide in the national highway, just almost 1 kilometer only from our IT campus. We do all sort of, number one, I think we need now a digital database and information system of the landslide in the Northeast. There's too many. And there may be a typological classification, type 1, type 2, type 3, so that we can develop some generic protocol to address these different landslides so that you don't have to really spend a great deal of time every time on each landslide. There could be established protocol to help us to at least go ahead with some site investigation very quickly. And then once we have that, clearly there are tools. We have our laboratories at IIT Guwahati are very sound. All kind of geotechnical investigation we can carry out, fortunately, and all kind of hydrological study we can carry out with IIT Guwahati. So we are capable of designing solutions, And then, as you have seen in case of Professor Sitaram's intervention, also starting from rock bolting to shot treating to slope stabilization, and a whole lot of study, RQD, for example. A very easy way to do it, but sometimes you have to depend on RQD itself. Then the whole rock mass classification we talked about, he's shown the beautiful example of wedge failure. All the rocks in the Himalayas are jointed. They're under tremendous stress condition. A lot of jointing are happening. The jointing per se can result into planar failure. But when 2 or 3 or 4 or 5 sets of joints crisscross, you develop wedges, and the wedge failure becomes a much bigger challenge. So you have seen that particular bridge issue there, that wedge failure is a challenge there. Fortunately, with all kind of steps taken so far, the design have been completed as far as the slope stabilization is concerned. But we should not forget that once the bridge is operational, we have to keep monitoring constantly what kind of problem can come in. So all that said, I'll not take more time because already you have listened to everybody, and I understand between Dr. Bharat and myself, we're supposed to be given 15 minutes. So I told Dr. Bharat that, first I'll initiate that it is a bit of a regional kind of understanding, and then he will make the presentation. But I hope to conclude that you have already got a very good idea about the intensive and extensive engagement that needs a project in terms of hazard mitigation. And we have seen the kind of engagement we have, smaller to bigger scale. The Northeast is full of landslide and other hazard issues. And we have a big thing to do here. We are capable. Of course, we need more support. And I think in the future, once our disaster risk reduction, we are looking at preventive management. We do not want too many landslides to happen. We're looking at, kind of resilience and sort of risk reduction, preparedness. So once we can do that, I'm sure the minimized kind of events that may happen with our capability, we should be able to address it. And we look forward to future engagement with NDMI in terms of more application-oriented work, field-based work, where my department colleagues, we have more than half a dozen people directly working on landslide and other hazard. We have about a dozen people on water resource engineering and management. We have structural engineering. We have other 7 disciplines. And lastly, we have an earth system engineering discipline, which looks at this tectonics and climate change issue in a much bigger scale. So altogether, I think institutionally, we'll be very happy to take the engagement that we initiated today forward. Thank you so much for this opportunity. I really apologize for the inconvenience that I could not come at the right time. I hope still we could make some sense together as 3 people from our institution. And I thank you again for this opportunity.
Thank you for highlighting the various case studies of landslides from Assam, Meghalaya, and Arunachal Pradesh. Sir, there is several questions raised by participants, and I'll take only 3 or 4 questions. Sir, both of you, as per your experience in the slide, what research gaps are there to fulfill now according to you?
If I can answer it, number one, that the linkage to the stress development due to plate tectonics, and then magnified by the other factors, we still have a lot of knowledge gaps. Particularly, as I have maintained, Northeast is a natural laboratory to study landslide. I can tell you that, both from rock types, from soil types, from stress development, from tectonic effect, and all that. Already DST has a big initiative. They keep coming to us. Manipur University is doing some work. There are nodal agencies under NRDMS, but it is not adequate. I guess as far as the intervention is necessary in terms of solving the problem, IIT Guwahati will be very happy to do that. And we have the capacity to, number 1, investigation, number 2, finding design solution, and number 3, also to help out in the knowledge transfer in actually implementing the design solution. But coming to the question, there are knowledge gaps both in terms of larger understanding, particularly the role of hydrology, for example, and similarly the intricacy of the role of soil, particles, for example, orientation, joint orientation, granular orientation. I can tell you one specific example. In the Northeast, a lot of these soils are micaceous soil, and the mica is a flaky mineral. Now, what is the additional role of this mica present in a particular orientation towards the slip direction is a very interesting topic in many European universities to study. We have not really gone to that sort of micro detail. I'm sure there are many such things that can help us to, make our solutions more robust, perhaps. Maybe Dr. Bharat can add to what I have said.
Yes, sir, I agree with you. Sorry.
Yes, sir. Please.
Yeah, I agree with Professor Mahanta. And there are other knowledge gaps that are available. Like, there is a intervention coming from geotechnical, water resource, and other disciplines should come together and then to address these issues. And moreover, when you have one of the landslides which I showed you near the IIT Guwahati, that the Jaiguru landslide, there is a soil and rock that were together, they were flowing. Debris flow has occurred with together. Especially in those situations, the soil characteristics, getting those soil characteristics is very difficult. Such things need to be addressed, and we are in the process of doing that. I hope we address the question.
Yes, sir.
Thank you.
Thank you, sir. Sir, there is one more question. Can remote sensing and geoinformation technology is helpful to carry out the slope stabilization?
Absolutely. That is, as I said, that's the first step. So because you cannot cover a landslide too quickly, so as soon as the slide happened, the Jaiguru slide we are talking about, the collector immediately consulted us, and one first thing we told him was to, hire an agency with drone and go up there and give us an aerial view of the whole slide. Because we are scared that the failure could have been maybe a planar or a wedge failure, and there may be more slip circle at the top of the hill, which cannot see from the lower part in the highway. So we thought that once these debris are removed and traffic resumes, if there is a second slide and it kind of buries some of the moving traffic, that could be really very risky. So we got a aerial survey done, and it gave us some idea about the kind of extra material that is to be excavated out, so that it's right now the vehicles are moving around. So that's a very clear example that you can, starting from a large resolution satellite map to a very low flying drone based kind of an aerial photograph. These tools can be very good time saving devices to take quick decisions. Of course, nothing can substitute each other. The geotechnical investigation is there, the geological understanding is there, the hydrological study have to be carried out. As Dr. Bharat has said, actually landslide and some related hazards are interdisciplinary, multidisciplinary. You need contribution from all these sectors. Then we look for a solution collectively based on the knowledge derived from this different specialization. And definitely remote sensing and GIS helps us to kind of develop, embedded solution, bringing this information layer together in a GIS platform and taking some what we call treating it as a decision support system. So what decision we take in terms of mitigation will be supported by the synthesis of the studies done by different disciplines and then put together along with the remote sensing study. So remote sensing study per se will not solve disaster problem, but it's a very good tool to understand and read the problem quickly and make some quick decisions when it comes to like clearing up a debris from a highway. You cannot really keep waiting long time because the traffic is held up. So I think in that sense, this is a very, very useful tool, and our calibration capacities are increasing. Our digital signatures are increasing from remote sensing. It is becoming handier, particularly with the advent of the drone and others. So, low flying applications.
Thank you, sir. And the last question is there any model for mud flow analysis that you have explored? Please elaborate the methodology of the same.
Dr. Bharat, you would like to address that?
Actually, the mud flow we haven't modeled as of now, but then we controlled. Actually, we gave a solution to control it, because if you see the daily rainfall data, after that particular day, there were also peak rainfalls that were occurring. I mean, more precipitation that was occurring, and then it was not stopping. We sensed that there was a danger that could happen. Then we actually intervened and we gave a solution to consolidate the soil over there quickly so that any hazard that would have taken place would have been overcome. So that worked well, and so far we didn't model that particular part, that how the mud flow can be modeled. I haven't tried at least.
See, the mud flow model will be a combination of sort of a hydrological modeling and a soil modeling, because it will be a kind of viscous material flowing. It has some characteristics of a flowing material like water. If you have seen, Professor Sitaram also referred to this one software called Rock Science. It has got a lot of modules. And within similar software, of course, I'm not saying Rock Science alone, it's possible to model. But as Dr. Bharat said, nothing of that sort of really come to us as a challenge so far. And because mud flows are generally little slower movement, we rather focus more on quick mitigation and intervention than really trying to model it, because it is not most of the time necessary also, unless you are really academically involved in a long-term large mud flow event, that what will be the progression and stuff like that.
Thank you very much. This answer will satisfy our participants' query. Now, move ahead with our next presentation. I would request Professor Surya Prakash, Head GMR Division, NIDM, who will enlighten us on the topic of climate change development and landslide risk reduction. I pass on stage to you, sir.
Dr. Harjeet, PowerPoint is visible?
Yes, sir. But make it full screen, sir.
Yeah, I'll make it full screen. Okay, now is it full screen?
Yes, sir. Yes, sir.
Okay, friends, my previous speakers, they have actually informed you about site-specific issues related to diagnosis and treatment of landslides, particularly focusing on infrastructure and construction works related to civil engineering departments. Now, let me take it as a challenge for the regional development sector large within the country. So we will talk about first, these days, pandemics is very much predominant these days. So before I go ahead with my PowerPoint, it's my duty to consider the Prime Minister's movement and campaign at present going on. That 3-step process: wear your mask properly. Wear your mask properly. Second, keep social distancing. Third, keep hand hygiene. Wash your hands regularly and do not touch your face oftenly. So these are some of the things which have been taught repeatedly by our experts, and also requested and recommended by all others. So I would like you to kindly focus on this coronavirus prevention, and just showing you some of the slides which are focused on the message given by Honorable Prime Minister, that no carelessness until there is a cure. No carelessness until there is a cure. Jab tak dawai nahi, tab tak dhilai nahi. So it's my request to all the delegates, participants, and the honorable speakers to kindly follow the recommendations made for coronavirus prevention and protection from corona. So in your offices and wherever you are going, kindly follow these 3 steps. Frequently wash your hands with soap, wear your mask properly, and maintain social distance. Now I come to the subject matter, that we are talking about climate change and its impact, particularly in the hilly areas in terms of landslides and related disasters. There is a Czechoslovakian proverb: misfortunes enter when window is left open to them. So we are always making some errors in our calculations, or there are some uncertainties or unknown parameters which actually become driving factors for the disasters to happen. Now, next, I wanted to focus that we have to bring to your knowledge about our SFDR, Sunday Framework for Disaster Risk Reduction, where we have 4 priority actions. and 7 targets defined. So it is very important for all disaster managers to remember that first priority action is understanding disaster risk. This is what we are trying to learn, that what are those governing parameters which are affecting the occurrence of these disasters with changing climatic condition, urban development and growth. Then the second is strengthening disaster risk reduction for resilience, how we can do that. The third is investments in disaster risk reduction for resilience, and fourth is enhancing disaster preparedness. Now this is what we are trying to do through these awareness programs. These are the 4 targets, and 7 targets are 4 priorities and 7 targets. The targets are substantially reduce disaster mortality, reduce the number of affected population, reduce direct disaster economic losses, and reduce disaster damage to critical infrastructure and disruption of basic services. So this is what we are trying through learning process and understanding them. The last 3 are increase the number of countries with national and local disaster risk reduction strategies. We need to have them both at the local level, at the national level, substantially enhance international cooperations, collaborations, through and complement national actions for implementation of the existing Sendai framework for disaster risk reduction. The 7th is increase the availability and access to early warning. Multi-hazard early warning, it is recommended early warning saves lives. And this is what some of the participants were asking for, that we may be good in diagnosis and treatment. What about those landslides which have not yet occurred or which are likely to happen or impending disasters? So we have to have a prognostic analysis as well as early warning systems for this. Another intention I would like to invite for sustainable development goals. This is what we are actually focusing in terms of sustenance for development and growth. And this would be possible only not by just taking the construction works, but also looking into the economics, malnutrition, hunger, gender equality, education, hygiene, then infrastructure development, and inequalities, responsibilities, climate action, and also caring for natural resources in terms of air, water, and land. So for all this, we have to have a social justice and fair approach with partnerships with all. So 17 sustainable development goals must also be considered along with our Sendai framework for disaster risk reduction. And the third point, where we have focused in the confined geographical area called hills, in terms of climate change, where these hills are affected the most in terms of the impacts of the climate change. And we had this agreement, Paris Climate Agreement in 2015, where Honorable Prime Minister also participated. And we focused on bringing down the average annual temperatures, which are creating more problems, and also reducing the pollution to the maximum possible levels. The another parameter which is driving the occurrence of the landslides is urbanization. Areas which were never seen or witnessed landslides have also seen landslides now in these days because of urbanization, development, and growth in those areas. And this is likely to increase with time. So we have to take care for this, and we have to actually do it in a very planned manner, considering the vulnerabilities and the hazard susceptibilities related to floods, related to earthquakes, related to landslides, wind hazards, and in a multi-hazard perspective as per our national policy on disaster management and landslides, which has been published by Building Materials Technology Promotion Council. Now overall, if we see, we have a lot of hazards and they come together, and as a national policy, we don't see them in an isolation. We see them in an integrated and holistic manner in a multi-hazard approach. So this is briefly about the occurrence of different hazards in the country. That is 65% of our land area is prone to earthquake, 12% to floods, 8% to cyclones, 70% to drought, and 85% to other natural hazards, and 22 states out of the 36 states and UTs are considered as multi-hazard. Now, if we look into the number of incidents, we find there is a change compared to geophysical hazards in terms of earthquake or other geohazards. The hydrometeorological hazards, their frequencies and severities and intensities are increasing in terms of epidemics, in terms of wind hazards, or in terms of floods. And some of the events which have been rendered as attributed to the climate change are Leh flash flood, which happened in August 2010. You can see the scenarios. Flash floods, Kedarnath flash floods, and landslides, which happened in June 2013. And also the Darjeeling landslides and fresh fires in 2015 and 16, and some other landslides. Considering all this, we had the Asia Ministerial Conference, because disasters do not know any boundary, and Honorable Prime Minister has given us a 10-point agenda, which is actually focusing on all the 3 agreements I just informed you prior to this. So all these 3 agreements were actually summarized in this 10-point agenda by our Honorable Prime Minister during the first post-Sendai Asia Ministerial Conference on Disaster Risk Reduction. Now I come back to the hilly areas. If you look into their developments, horizontally and vertically, they are going very intense. We are not caring for much for scientific and planned developments, and not leaving any space for disaster risk reduction and resilience. So you look at any of the hill areas, you will find both vertical as well as horizontal developments going on, and lot of deforestation, explosion, construction, mining activities, along with other kind of activities. So at the national level, we are having a national policy and a national plan. We are recommending to study, understand, and manage these kind of disasters with changing climate, urbanization, and development. And for the specific disasters also, we have specific guidelines for earthquakes, for landslides, for floods, and also for various operations and actions related to landslide hazards. While we were developing the national guidelines on landslides, we come across that not only the northwestern part or the northeastern part of the country, even the southern part of the country has been suffering from landslides. Kerala landslides are a very good example. In recent times, several catastrophic landslides had happened and killed many people. Besides that, even our central India, wherever the hilly terrains are present, landslides have been experienced. And we had also created a mega landslide hazard zonation map, and which was published at the national level, looking into the incidences of the landslides. And these landslides are actually not variable only across the space, but also across the time frame. And we found the number of landslides, they change in the same area with the every year annual occurrences of rainfall and seismic activities, besides the developmental interventions by the anthropogenic activities. Now I cite you some of the cases. I'll quickly go through these instances in our country that has happened. We started studying on landslides way back in 1867, and also in 1880, when a big landslide happened at Shekhardanda in Nainital, and more than 150 people got killed. And that was the first landslide which was monitored during the British period. This is an archival photograph of that landslide. And then Kalyasore landslide, and then this landslide. I'm showing you the latest photograph, 2013, when I crossed it after the Uttarakhand flash floods and landslides in June. And this was the situation just before it actually got triggered. Malpa landslide, which actually served as a turning point in landslide management, after which the Ministry of Science and Technology constituted 3 major task forces. So this was one of those landslides which had killed more than 200 people. And the famous dancer Pratima Bedi was also killed under this landslide. Beti Ponder landslide, which killed more than 100 people, 107 people. And the whole of the village was washed away, and the material went and override the slopes on the other side of the river as well. So there are many such landslides, Fata landslides, which killed 27 people. Large Hekla landslide in 2009, which killed 43 people. These are all instances where several casualties have taken place. This was the large Hekla village, which was in existence and which was completely washed away. We are not able to recover the people and save the lives of the people once they are trapped and buried underneath the landslide, and they get killed alive. So they are buried alive and they get killed under the debris, and it is very difficult to even rescue them from those debris, which is full of water, and their body parts are cut away by the blunt and sharp stones and rocks which are present in those areas. So Shumgar landslide, not only the elderly ones, even the children in a school which was affected, they got killed, 18 children on 18th August 2010, between the age of 4 to 10 years. When a landslide hit the school building from the back wall, which were consisted of a single brick. So these are situations, and the access to these areas also become difficult. And most of these incidents are happening either at late night or in the early morning hours. So response becomes very difficult. And innocent children, they become victim, and floods are another disaster which are happening and increasing in their incidences and intensities and severities, and as terms of climate change impacts. Then the earthquake-induced landslides. This was one of the hillock which was actually affected by 1991 earthquake on 20th October, which hit the Uttarkashi district. And slowly the water got infiltrated into that crack and surcharged the hill. And after the saturation in 2003, just after the monsoons were over, a landslide took place and the whole of the hill gave way and affected more than 400 houses. So these were the kind of hotels which were present just a day before the landslide happened and just a day after the landslide. So you can see many of those incidences which had happened as a result of climate change and also because of developments. And one of the measures which are often taking place in the hills to manage the landslides is posting of the bulldozers, JCBs, and the laborers. And this was one of the landslides which had almost more than 500 meters of height, where the bulldozer along with the laborers went into the river. 4 laborers were killed, and you can see this yellow sign where the bulldozer also went with the debris into the river. And Bastadi landslide, on 1st July 2016, when a landslide happened, some people tried to save locally those people who were trapped in the landslide. But later on, another episode of landslide took place and also engulfed those rescuers, which actually saved the people who were trapped in the first incident, and almost 14 people got buried. This was the site where this has happened in Bastadi village in the Pithoragarh district. And thereafter, it was very difficult to save those people. And in the Kedarnath flash flood tragedies, all the access routes and roads and even the buildings, they get completely damaged and lost. And not only for the public at large, even this is one of our strategic issues, because even the border roads, they get blocked because of these landslides, and our army personnel has to actually walk over the landslides to cross the area and reach to their borders for their duties. So we have to look into this, and oftenly people are parking the buses and their vehicles across the landslides, and this is one of those buses where another stone started rolling down from adjacent slopes of the landslide and hit this bus. We were witnessing this in front of us when this boulder came down and hit this bus, where 13 persons were inside this. Somehow a lady saw the boulder rolling down. She cried and the 13 people immediately came out, and this was the situation immediately afterwards. So those kind of, we are concerned not only about the landslide treatments, but also their impacts and response, and also prognostics and early warning systems, where they can happen, why they can happen, and when they can happen, and how we can actually inform the people in advance to protect them and prevent these occurrences. NIDM, one of the major hydel projects with 2000 megawatt capacity, actually the submergence of the areas leading to the saturation of the slopes and the instabilities, and causing many of the landslides along the reservoir rims, and not only taking away the hill slopes, the trees, but also the threads to the road on the upper sides of the slopes. Besides this, it's also reducing the reservoir capacities and may also sometimes cause big problems to the dam site itself, as we can remember the site which happened in Guwahati Dam in Italy in 1963, when the big landslide happened, and it threw away the water on the downstream side, and more than 3,000 people got killed on the downstream side of that dam site. So we have to be very cautious in this. And these landslides are not only causing problems along the reservoirs, but in the river systems also, and blocking the rivers at the night and creating transient lakes, and then taking away the roads close to the river, and also creating flash floods. This was in 2005 when the Lambgad landslide took place, and in Canada and Yamunotri Valley. Many instances I can cite. And I'm not citing these from literature, I'm citing from the sites which I visited, which we were involved with. So these are so many instances. Patalganga in 1970, very famous landslide, which actually caused so many casualties. Almost 300 villages were affected by this Alakananda flash floods and landslides in the August 1970. And these are the situation because of geographical, very steep slopes and narrow valleys. They cause most of the problems because they can easily get blocked. And then when the blockade fails, the flash floods and landslides happens, and these can be identified geologically, geographically, hydromorphologically. There are many other parameters, and meteorologically we can identify, we can assess, we can forecast. So why we are not able to contain landslides, which are one of those geohazards which has the highest potential for prediction, prevention, mitigation, and management. So we can identify which are those areas which are affected by landslides, because they are normally either loose unconsolidated materials which can easily flow and give way under the force of the gravity, or these may be highly dissected and fractured rocks and materials, maybe because of foliation, because of tectonic structures, folds, faults, or joints and shear zones, and all these can be easily mapped well, and we can know the areas. And also they give indications for the common people also, that areas which were not wet before suddenly become wet, and areas which were wet where water was flowing out suddenly become dry, indicating the subsurface blockade or diversion of drainage. So all those, or suddenly appearance of cracks, since
Hello, sir. Are you there? Hello. Sir, we are not able to hear you. Hello, sir. Professor Surya Prakash, we are not able to hear you. Sorry for the inconvenience. Kindly give a 5 minutes. We will directly contact with him.
Dr. Harjeet, actually, the power is out in the office. Am
Sir.
I? Can you listen to me?
Yes, sir. Yes, sir. Audible, sir.
Okay. I'm sorry, we will not be able to make the PowerPoint presentation. But my views were that we can identify the precursors and also understand the indicators of a landslide. Suddenly, they are always giving us some indication which need to be understood properly. So we know the geo-environmental conditions under which these landslides happen. We know their indications, and also if you know the indications, you can actually warn people for measures and also guide them to protect themselves. So particularly in the habited areas and also areas which have elements at risk, maybe the hydel projects, bridges or buildings that may be threatened by landslides, flash floods or related disasters. Think of them in a multi-hazard perspective, and there are a lot of techniques available for landslide remedies. For applying those techniques, you have to actually identify the exact process of failure and its runout distance along with the volume of the mass and the velocity of the mass that is likely to move. Using all those calculations, we will have all the potentials to prevent, mitigate, and manage landslides. These are some of my suggestions in this webinar. We had other webinars also focusing on landslides only, where we have not discussed with in relation to climate change and development as well as sustenance. So here my concern only to communicate with all the participants is that kindly look into this literature. NIDM has actually made it publicly available, our training module on comprehensive landslides risk management. And also we have published a book recently on construction of buildings on landslide prone areas. So those materials can be consulted. Besides this, you can learn more about landslides risk reduction through our web portal nidmssp.in, where we have a dedicated audio visual program on landslides risk reduction and resilience. So these are some of my suggestions which I would like to present. I would say कि जगाना आता है उसे कई तरीकों से, दरों पर दस्तक देने खुदा नहीं आता, पड़े रहो सहमे हुए यूं ही अगर हवा के पर बांधना नहीं आता. You must learn to know about disasters so that there are no disasters. So learn about disasters and tame disasters rather than getting tamed by them. This is what I would say. And thank you very much. I'll conclude my presentation here.
Thank you very much, sir. Sir, one of participant, Mr. Ritvik Nigam, he asked, due to climate change scenario and rapidly changing rainfall pattern, should we conduct landslide susceptibility assessment in interior part of Goa as it is not prone to landslides?
Goa is very much prone to landslides. In fact, Goa had many landslides. I remember the Porvorim landslide, which actually blocked Goa from the adjoining states for more than a month. And the problems in Goa is that they are mostly lateritic materials, which can easily get weathered, and the water can affect the quality of the rock marble. They have to actually study it very systematically, because Goa also has culturally sensitive area, heritage areas, where general interventions may not be possible. So for management of landslides in Goa, particularly focusing on those old Portuguese colonies and heritage areas, separate kind of investigations and management may be required than what we normally apply in other hilly terrains. So Goa had actually some landslides which had even killed people as well. And because of little experience by the administration and authorities in Goa, some of the casualties actually happened because of wrong actions during the rescue operations. Normally in a landslides, you may not find the people buried at the same site where they were present before the landslide occurred. They actually get moved away along with the landslide mass. And they, in Goa, when one of these such landslide happened, they were searching the people at the same site where they were using a bulldozer, and that bulldozer actually moved over those bodies, and the people got killed. So those kind of actions are also quite possible if we are not knowing actually where to locate those bodies which has moved with the landslides. In the hilly terrain, normally they come to the lower parts and they are not located at the same site. So Goa has problems of a different kind with a specific kind of geology. Coastal landslides are also possible in Goa because there are coasts. It's very close to ocean, and submarine landslides are also possible. So Goa may have coastal landslides, submarine landslides, and also terrestrial landslides. So all kinds of landslides are possible in Goa.
Thank you very much. I think this answer will satisfy our participants' question. And with this, we come to end of our technical session. There is one announcement that ED and NIDM is not able to join us due to some other assignment. Now I would like to invite Professor Surya Prakash for his concluding remarks.
Thank you, Dr. Ajit. In the concluding remarks, I would say that we have actually tried to share the technical expertise, infrastructure available with our academic organizations, academic and research organizations other, which has got good experts also available with them, and also their experiences related to the case studies. None other than the director IIT Guwahati himself has shared the rich experience of a bridge, railway bridge, which has been constructed at the highest level in the world, and with using the piers, abutments at different levels, using our best of the science and technology, along with almost all techniques, tools that were available at that time. So we can be proud of our technical expertise in terms of strengths to which has been demonstrated through that construction works, and also assessments done on landslides. However, that is may not be good enough because landslides are versatile, widespread, frequent, and sudden in our country. So maybe for the major projects, they can be well studied, diagnosed, and treated. However, at the local level, community awareness and preparedness is very much required. So we must look into that and take care of the landslides through the precursors, indicators, and the treatments which can be locally undertaken with support from the local communities and the local line departments, right? So this is what I would suggest, that people have to learn in harmony with the nature, learn to live with the landslides by identifying them properly and then managing them well. So this is what is my suggestion, that we can go for urbanization development, looking into the climate change aspects as well as our ecosystem and hill environment. Then only we can live in harmony and avoid the impacts of the disasters. So let's try to identify this, and then we can go for sustainable, safer, and long-term developments and growth in our country, in the hilly terrains. Thank you. for giving me this opportunity for the concluding.
Thank you, sir, for your concluding remarks and motivating our participants. Now it's time of thanks, and it's my privilege to have been asked to propose a vote of thanks on this webinar. I wish to express my sincere gratitude to Professor T.G. Sitaram, Director IIT Guwahati, for sparing his precious time from his busy schedule for providing encouragement and support to all of us. Also, I wish to express my gratitude to Major General Manoj Kumar Bindal, Executive Director NIDM, for his encouragement and support in our every endeavors. I must mention our deep sense of appreciation for Professor Chandan Mahanta, Head Civil Engineering Department, IIT Guwahati, Dr. T.V. Bharat, Associate Professor, Department of Civil Engineering, IIT Guwahati, and Professor Surya Prakash, Head GMR Division, NIDM, for their presence to enlighten the participants with their vast knowledge and experience. I also express my deep sense of appreciation to Professor Surya Prakash, who is the Head of GMR Division and Program Chair for this webinar. And last but not least, I am thankful to GMRD team, Mr. Anil Katath, who is the coordinator of the webinar, Mr. Raju Thapa, host of today's webinar, Shobhit and Balaji, for making this event successful. And for the participant, there is no need to worry about the attendance. Software automatically generate your attendance, and feedback link is shared in the chat box. Those who could not fill up the feedback form, you don't need to worry. We will share the link to the participant later. And for the next program, we have 3 days online training program on hill area environment and development with focus on landslides, earthquake and flood from 21st to 23rd. And on behalf of NIDM and IIT Guwahati, we wish all the participants a healthy and safe life. 2 गज की दूरी और मास्क है जरूरी to fight against COVID-19 spread. Let us do all our part at individual level fight this global pandemic. Stay healthy, stay safe. Thank you. Now I request host to close the meeting.
Okay, ma'am. So, Anil sir, should I stop this meeting?
Yes, Raju.
Okay, sir. Okay, thank you, everybody.